Hello everyone. In today's session, we are going to see Towers of Hanoi problem, which is the very important problem using recursion. So first we have seen factorial, second one Fibonacci number. The next problem we are going to see is Towers of Hanoi. Let us go to the problem. Now what actually mean by the Towers of Hanoi problem? In Towers of Hanoi problem, we have given three pegs. We call it as pegs. First one is peg A and second one is peg B and third one is C, right? Instead of using the term peg, we can also use pole. The first peg is A and second one is B, or we call it as this is source, right? And the last one C is the destination. The middle one we call it as auxiliary. We have given three pegs. So in the first peg A or source, we have given a set of disks. We have given a set of disks. See the topmost disk I am giving as the number 1 and this is number 2 and this is number 3. We have given a set of disks on the source peg. Okay. Now what we have to do? We have to move all the disks from the source peg to destination peg C via auxiliary, or by making use of auxiliary peg you have to move all the disks from source A to destination C. So finally what we are going to get, the final representation of this is three pegs. Okay, this is A and this is B, and here we have to have on the C peg we must have all the disks like this. This is 1, 2, 3. This is the final result. This is the initial state and this is the final state. So only the thing is we have given a set of disks on the source peg. We have to move all the disks from the source peg to destination peg. That is the logic. Now, what are the conditions or the constraints to move the disks from one peg to another peg? That we have to see. See, the important thing, the conditions you have to satisfy are the first one. Only one peg, sorry, only one disk should be moved at a time. This is the first important condition or criteria. Only one disk should be moved at a time. After the second thing you have to remember is only the top of the disk should be moved, right? This is the second condition. And third one is larger disk should not be placed on the smaller disk. And fourth condition is move all disks from source peg to destination peg. So I have given numbering, right? So 1 is smaller than 2, 2 is smaller than 3. When we have given 3 disks, 1 is the smaller disk compared to 2, 2 is the smaller disk compared to 3. The number of disks here is n. You can give any number of disks, not only 1, 2, 3, any number of disks you can give. So in our example, we have taken only 3 disks, but you can give any number of disks. See, if you have only one disk, if you have, this is A and B and C, if you have only one disk, then how to move the disk from A to C? Directly you can move. only in one step. Only in one step you can move the disk from A to C. That is simple. Now when we have two disks like this, 1 and 2, how to move the disks to the destination? This is B and C. So in this case, move the disk 1 to B. Okay. Now move the disk 2 to C. Right. This is disk 1 and this is disk 2. After that, move the disk from B to C. This is the logic we have to use. So like that, if the number of disks are increasing, then the procedure becomes very complex. So in that case, the recursion is most useful. We will see how the execution will be done by using the recursion. Now we will see how the execution will be taken place. See here, if you observe this code, so the function we are discussing is about towers. We know that in every C program, the execution starts from the main. Now we will see the execution part of Towers of Hanoi problem with a tree representation. If you are able to understand this tree representation, then the program is very easy. So let us see this. Assume that from the main, we have called the function. The function is here is towers. We are calling towers function. Assume that we have given the number of disks 3. Source is peg is A. This is the middle one and this is C. This we call it as N. This is beginning peg B. This is auxiliary peg A. C is the end peg, right? Now, main is calling towers by passing these values. Now, what you do is this, you treat this as the root node. From this root, you go to the left. Okay. Now, in the left, what you write? You write towers. Now you take n minus 1. How much? 2. Now the left side towers, what it is going to do is, the left side towers mainly talks about the source is the starting peg, the destination is auxiliary peg, the source is beginning peg. What is that? A. Now the destination, what is the destination? This is source and last peg is the destination. Last peg is the destination. For this, the destination is B. The remaining is left is B. I am writing like this. This is like. Now this becomes N and this becomes B and this is A and this is E. Now again move left. Again you call the same towers. N minus 1 you take 1. Now just now I said that for the left towers, starting peg is A, beginning peg. What is beginning peg here? A, comma. The destination, last one is the destination. Destination is auxiliary. What is the destination? C. The remaining is B. Remaining I am filling with the left one. Okay, A, B, C. Now you change this N. This is beginning peg. This is auxiliary peg. This is the end peg. Okay, we are moving from the starting node to left, to left, to left. So, at how much distance you have to move until you get the number of disks is 1. Now, here we got 1. When n value becomes 1, what you do is, here I am writing the steps for movement. Now, when n value is 1 here, you do one thing. Move disk 1. Move 1 or simply say 1 is moved. Just I am writing like this. 1 means disk 1 is moved from source to destination. What is the source peg? Beginning peg A. destination means end, from A to C. Disk 1 or 1 is moved from A to C. This we have executed, right? Now left we have completed. Left we completed. From this left we are moving to the root. When you move to the root or parent, previously this is the left to child. For the left to child, if n equals to 1, we have printed this. From the left to child, we move to the parent. When you are at the parent, go to print and you print the value here is, what is the disk here? N. N value how much? 2. Here you write 2 is moved. Another print we are using, 2 is moved from, what is beginning peg? A. What is the destination peg? B. A to B. A to B. Right? Now, see, we are printing 2 times, when n equals to 1 and when we are at the root node. Now, from here, you move to right. Okay, right towers again, you go to right and you call another function towers. So left completed, root completed, and moving to right towers. Now right side, what you do is, right side you take the number of disks n minus 1, how much? 1. Now right side towers, what it is going to do? It is going to treat that auxiliary is the source, and the end one is the destination, and it is going to write the remaining in the left. So here, what is auxiliary? Auxiliary is C. Okay. Now last it is going to write destination. What is the destination? B. So CB completed. What is the left one? A. So it writes like this. So auxiliary to, it is taking auxiliary. What is the auxiliary? C. And destination is B. B. End is B. So remaining left one is A. Now this becomes N. This becomes beginning. This becomes auxiliary, and this becomes end. Now when n equals to 1, again we have to print, right? Now you print, what is the print? Move, or 1 is moved. 1 is moved from, so what is the beginning peg? C. What is the end peg? B. C to B. C to B. Now see here, this completed and this is also completed, and this part I also completed. Now for this, n equals to 1, one printf is executed. When you move back towards, another printf is executed at the root. On the right side, when n equals to 1, first printf is executed. These three, all these three are completed. Right now, you move back. So when you consider this, this is the left to child, left subtree. Left subtree is already completed. Now we are moving to the root. When you move to the root, we have to print, right? Root also you have to print. Now what do you print here? N value. What is n value? 3. Now 3 is moved. You write 3 is moved from, what is the beginning? A. What is the end? C. From A to C. Okay. Now after this, root completed. No. What about right? Right is not completed. Now go to right. Here you write again towers. N minus 1. 3 minus 1, 2. But when you go for the right towers, I said the source pole becomes the auxiliary. What is the auxiliary? B. The destination pole becomes end. What is end? C. What is the remaining? A. B, A, C. Just here I am writing auxiliary and end last. In the remaining I am filled with the left poles. This is right. Okay. Here if you observe this, here n value is not 1. When it is 1, you print it, but it is 2, right? So here for this, you can move left. After that, you move right. First go to left. Now you write towers. towers. When you go for the left, what is the logic you have to use? N minus 1, that is 1. Okay. And you know this is N, and this we call it as beginning peg. This is auxiliary peg, and this is end. Left 1, right? Now left 2 means you write, whenever we say left, source to auxiliary. What is source? Source means beginning peg. What is beginning peg? B. Now destination is auxiliary. What is auxiliary? A. The remaining is C. So we call N, this is beginning, this is auxiliary, and this is end. So here N equals to 1. When N equals to 1, print. Now 1 is moved. 1 is moved from B to B, right? B is the beginning peg and A is the end. B to A. B to A. Right? This is completed. Now you move back. When you move back means this is root. When you go to the root, then print another print. So now in this case, you said 2 is moved from beginning. What is beginning? B. What is end? C. B to C. B to C. B to C, right? Now after this, move right towers. Okay. Now after this towers, what is N minus 1? What is that? 1. Next to right means what you do is you take auxiliary. What is auxiliary here? A. What is the end here? C. What is the remaining? B. Okay. This is N. This is B, A, E. Now in this case, again we are getting 1. In this case, what? 1 is moved. 1 is moved from what is beginning? A. What is end? C. 1 is moved from A to C. This is also completed. Now in this case, what happened? This right part is also completed. Now left completed, root completed, right side also completed. So total how many steps? This is 1, 2, 3, 4, 5, 6, 7. 7 steps. So with these 7 steps, we can move 3 disks from source pole to destination pole. This is the very, very important logic. I think it is understood. Otherwise, we will see in the next class. With this, I am going to close the session. Thank you for watching.